This is problem number 9, and what we're asked to do is to solve this system of two equations and two unknowns. Now we could solve this using the method of elimination by addition, where we eliminate y, get x, and then eliminate x and get y. But the directions of the problem tell us to use matrices. Now if you're already familiar with matrices, we're just going to go ahead and I'll start working. But if you're not, then you should go here on our YouTube channel. Just go into chapter 0, which is titled Discussion on Systems, and view videos 8, 9, 10, and 11. Now 8 deals with an introduction to matrices. 9 is how to put a system of equations into matrix form. 10 is how to row reduce the matrix, and 11 is solving the system using row operations. Now I'm going to put this system into the augmented matrix. It'll look like this. I'm just going to go down the columns and put in those coefficients of the x's, -3 and 1. The next column I'll put the coefficients of the y's, 4 and -7. And then instead of an equal sign, I'll just put a vertical line here. And then I'll put the constants, -2 and 8. All right, this is called the augmented matrix. Could you go backwards? Could you see where this comes from? X column, Y column, -3x plus 4y equals -2. Now to get this into row-reduced echelon form, here's the idea. Here's where we're headed. I'm going to try to get into this form here, where I'll get a 1, a 0, a 0, and a 1. And on this side, I will put the solutions, which turn out to be -18 over 17 and -22 over 17. Now, where did those come from? That's what we'll find out. But what I'm trying to do here is this. I'm taking my original augmented matrix, converting it to this form right here. Now, this is called the row-reduced echelon form, RREF, row-reduced echelon form. And you can see that we have 1s on this diagonal here. Now, this is called the main diagonal. As you go top left to bottom right, it's called the main diagonal. 1s on the main diagonal, 0s everywhere else. So you can read this answer off here, right? What do you have? 1x, no y's. So 1x is -18 over 7. And down here you have no x's, but 1y is -22 over 17. Now, the question is, how do you get from here to here? All right, so what we're going to do is we're going to use row operations. So let's do that. Now, I see that I want a 1 in this position, that top left position. I could get a 1 here by dividing this entire row by -3. But if I do that, right, -3 over -3 is 1, but now I'll end up with fractions. I try to avoid those. But I see this. I got a 1 here. Now, this 1 is in the second row. That's just the second equation. Now, the whole system's the same. Doesn't matter what order I write the equations, this one and this one below it, or this one up here. So I'm just going to swap rows. So I'll do this up here. I'm going to say what I'm going to do. I'm going to say that row 1 and row 2 are going to change positions. So you might read the notation like this. Row 1 will become the arrow. Row 1 goes to row 2, and then row 2 goes to row 1. Right, so I'm just switching these. So down here, I'm just going to switch these, and it now looks like this. I'll write the second row first. 1, -7, a vertical line, and an 8, and then a -3, a 4, and a -2. Now this 1 in that top left position, I'm going to call that my pivot element, and I'm going to eliminate this -3 here. I'm going to make it a 0 by pivoting on that 1. So I'll just circle it here so I know it's my pivot. Now what I'm going to do is I'm going to use row 1 and row 2 and eliminate that -3. And doing so will remind you of solving the original system using elimination by addition. So here's how I'm going to do this. I'm going to replace row 2 with, all right, now what I want here is a 0. So I'm going to multiply this row by some number and then add it to this row. It always works like this, okay? Every time. Take the opposite of this number, multiply it through that row. So the opposite of negative 3 is positive 3. Multiply it by the first row, and then add that to the second row. So what I'm saying here is that the new row 2, I'm going to get by adding the current row 2 to 3 times row 1. Now if you take 3 times row 1, 3 plus negative 3 is 0, right? And I get a 0 there. So I'm going to write what it looks like. So take this 3, multiply it all the way through equation 1, or row 1. It looks like this. 3, negative 21, and 24. Now I'm going to circle that, and then I'm going to add it to that row, just keeping track of what it is I'm doing. So let's do this. Here's the new matrix. So I'm going to keep row 1 the same, right? No change in row 1. That's going to be a 1, a negative 7, a vertical line, and an 8. And now row 2 is going to be the current row, right here, added to this row. Just component-wise, first and first, second and second, third and third. All right, so first and first, negative 3 and 3. That's the 0 that we were looking for. Then, where are we? We're at 4 and negative 21. All right, 4 and negative 21 is negative 17. And then, negative 2 and 24. Well, that's 22. Well, now I need a 1 in this position, right? I got a 1 here, a 0 below it. Now, go down the diagonal. So it's like you start at your 1, your pivot, and then go to the right one, down 1. If we had a bigger matrix, I keep going. The right one, down 1, right one, down 1. Just right down that diagonal. So here we are. I want that to be a 1. So I'm going to divide this row by negative 17. It looks like we're just kind of stuck with fractions. That's how it is. So here's my plan. Row 2 will become the current row 2 divided by negative 17. Then here's what the new matrix looks like. First row stays the same. 1, negative 7, vertical line 8, and then divide every number in that second row by negative 17. We'll get a 0, right? 0 divided by negative 17 is 0. Negative 17 divided by negative 17 is 1, and then 22 over negative 17, I'll put the negative on top, negative 22 over 17. Now, we're close. I've got a 1 in that position. I just need to get a 0 in this position. So this is going to be, that 1 is going to be my pivot. I'll just circle that to remind me that that's the pivot element. I'm going to replace row 1. So row 1 will become, or I take the opposite of this number, which is 7, multiply it through that pivot row. Opposite of the number, multiply through the pivot row. So it's going to be what? Positive 7 times row 2, and then add that to the current row 1. Now it's going to look like this. Take that 7, multiply it all the way through here. All right, so that's going to be, what? 0 times 7 is 0. 7 times 1 is 7. And then 7 times negative 22 over 17. And that comes out to negative 154 over 17. So our new matrix is going to be, now what do we get here for the first row? That first row is going to be this row here that we just got added to the original, the current row 1, component-wise. So what do you get? First plus first. 1 and 0 is 1. Then I'll get that 7, add that to negative 7, that's 0, that's what we were looking for, our vertical line, and then we're at the negative 154 and the 8. Okay, we're going to add 8 and negative 154, a bit of a challenge. Let's do that off to the side here. Here's what we're looking at. We're looking at 8 plus a negative 154 over 17. So I can do it like this. Let's get everything over 17. Well, it's really a minus here. Let's just do that. All right, now 8 times 17. Well, that's 136, and then minus 154. That is negative 18 over 17. So that's going to go up here. So that'll be negative 18 over 17. Our row 2 stays the same. 0, 1, negative 22 over 17. And now we can read off our answer here, right? What do we have? 1x, no y's. So x is equal to negative 18 over 17. You know what? That's almost readable. Let's try that again. It's negative 18 over 17, and y is equal to negative 22 over 17. There we go. Now, no doubt, this is cumbersome and time-consuming, and a lot of places to make mistakes, right? Look at all this arithmetic through here. So is there a better way? Yes, there is, and we're going to use that. We're going to use some technology called Wolfram Alpha to get us from here to here in a matter of seconds. But we're going through all this to show you what the computer is doing and to give you a good idea of how this whole method works.